So in this first video on limits, we're just kind of doing a basic intro. Limits are fairly important. We've looked at them a little bit throughout the year, but when we get into calculus, they really help us understand some of the main components, specifically things called derivatives and integrals. So it's important that we have a good foundation in this. For the first little bit, we're just going to look at some basic examples, nothing that's too difficult, but just something that's trying to give you an idea of what a limit actually is. So maybe we'll start off with a bit of a review example. If we had to sketch the graph of x squared minus 4 over x minus 2, initially it looks kind of complicated. We might have to go through that process that we did with graphing rational functions a while back. But for this particular one, we could also just work on factoring this a little bit. And so if I took that numerator and I broke it apart, I would get x plus 2 times x minus 2. And the denominator is just x minus 2. And so these things would kind of cancel off, and I'm just left with the idea of x plus 2. Okay, so if we were to take that and then to think about what the graph of that would look like, we might need to answer part A here first. We have to think what's going to happen at x equals 2. And based on what we've looked at so far, there's going to be a hole. So as I go in and I try to graph x plus 2 rather carefully here, I know that my y-intercept is at 2. Whoops, let me get my pen back. Do that, okay. So I know my y-intercept is at 2, my slope is 1, and I get up to here and there's going to be a gap right there, and it keeps going. It's doing it all the way down here, so it's just a line. But the big idea is that there is a hole right there, and that's kind of the idea that we need to take away from the sketch. And so when we start to talk about limits, what we're going to try to do is figure out what's going on, or how would we describe what's happening at 2 itself. Now if I go back to the original function, I can't plug a 2 in because I would be dividing by 0. But if you think about it, when I plug a 2 into the numerator as well, I get, if I go through that work, 2 squared minus 4 is 0, and in the bottom 2 minus 2 is 0. Whenever I get 0 over 0, usually that's a good sign that something nice could happen if I wanted it to. That I can somehow simplify and figure out what's going on at that value with enough work. So one thing we could do is we could just kind of look at a table of values. So I'm going to pause this a second and fill in some values that I just got from a calculator from making a table and plugging some things in. We just want to look for a pattern here. So I'm going to plug in a 1.5, a 1.75, a 1.9. I'm always going to plug them in basically into the original function, but I could also be plugging them into x plus 2 because they're somewhat equivalent. So as I plug the x values in, you can see what I am left with. It's always 2 more than the x value. But what we're doing is we're trying to look for a pattern. So my x values are not going up by the same amount. I'm actually getting a little bit more specific, or a little bit closer to 2 every single time. But what we tend to see is that there's a pattern, that even though I can't plug a 2 in, it sure looks like it's getting close to a certain value, and graphically I can kind of see that as well. It sure looks like it's getting close to a y value of 4. So at this point we should just kind of think, what is a limit? What's a way of describing it? So if you look in the box there, basically what this is saying is if I'm looking at a certain interval and I want to pick an x value to investigate, that if I just keep getting a little bit closer to it, a little bit closer, a little bit closer to it, I'm just looking for a pattern of what y value is it getting close to. So if we can see that it's approaching a y value of L, we're now going to say that the limit as x approaches that specific number that we're interested in of f of x equals L. So we have to be somewhat familiar with this notation right here. Okay, this is saying look at a certain x value, that's the part right there, in this function, and what is the y value that it's getting close to. So that's what the L means. So applying this definition to the function above there in part C, what's the limit as x approaches 2 of the function f of x? What does the function seem to be getting close to at x equals 2? It sure seems to be getting close to 4. Then we'll just go through one more example here. Use the graph to find the limit as x approaches 2 for function g, and you can see that function g is a piecewise defined function, so it is 1 for pretty much every x value, but then at x equals 2 it jumps to a different value. Alright, so I'm going to try and erase, I think, if I can figure out how to do that. I'm not sure if I can. Let's see what happens if I move it around. Okay, that 4 is just going to be stuck there for a second. But I'm going to try to graph this function here. So it's going to be 1 for most places. Okay, but at 2, it's going to drop down to 0. So at 2, it's right here. But everywhere else, except at 2, it's at a value of 1. Okay, so even here, we're going to be able to see that there's a limit, because if I just look, what's the pattern as I'm getting closer and closer and closer to x equals 2, from this side and from this side, it sure seems like it's kind of heading to the same value. It's heading to 1, even though at x equals 2, it has a totally different y value. That is still okay. So let's see here. So I'm looking at kind of answering this part right here. What is that limit? That limit would equal 1, even though the function at x equals 2 is defined totally differently. It's just what's the pattern as we're getting close to it, and that's kind of the big takeaway for a limit. So again, let me just kind of summarize that. It's what's the pattern as we get close to that x value, not the actual y value there. It's just what's the pattern, what's the thing that we seem to notice, what's the level or the height that it seems to be getting closer to. That's, in the end, what a limit is.